guys! Alright, so we are ready for math today. We are going to warm up with a sprint, get a good blood pumping. It is called analogous addition sentences within 40. And that sounds super duper fancy, but all it means is problems like 1 plus 1 is 2. 11 plus 1 is 12. 21 plus 1 is 22. We're increasing by groups of 10. We did that very recently, actually. And what's happening in the ones place is where the change is apparent in terms of each individual problem, but based on the pattern, it's the going up by a group of 10. You've seen this before. This is not new, I promise. It'll look better when you see your problem set. I mean, not your problem set, but your page, which is page number 31, and it looks like this. And you're going to write the missing number. Just looking at it from here, I see that for each problem, we are missing the number on the side with the number by itself is what is missing until we get to this last little couple right here. But like I said, it's page 31 in your Starry Night Fluency book. And what we're going to do is I'm going to put 60 seconds on the clock, just like with any other regular sprint. You're going to do your best, and then we're going to check our work. So let's go ahead and put 60 seconds on the clock, which is the same as 1 minute. So 1 minute on the clock. On your mark, get set, go. The bell actually rang this time. Hot dog. That's exciting. Alright guys, but that does mean time's up. So let's go ahead and stop here and check our work and see how we did. Come on. Okay, now let's go ahead and check our work. Starting at number 1, we're writing the missing number. Remember, these are analogous addition sentences, meaning number 1, everything is adding, and number 2, we are trying to look to find the whole. We're still on page 31. Number 1, 5 plus 1 is equal to 6. 16. 26. 6. 16. 26. 8. 18. 28. 8. 18. 28. 7. 17. 27. Alright guys, top of column 2, question number 16. 6 plus 3 is equal to 9. 19. 29. 8. 18. 10. 20. 30. 11. 21. 31. See, I had to pause and think about it because I completed a group of 10 and then I still had some ones left over. I had to think about what was happening. 14. 24. Alright, notice these last two questions we are now missing a part. So to go from 29 to 34, 29 to 34, what is the change we are making?
it's 5, 20, well, I'm going to count it out. 30, 31, 32, 33, 34. I want to count on, and I see that it is 5, okay? And then here is 9, and I want to draw your attention to, look, in the ones place we have 9. And then we said this answer was 5, so 9 and 5. Here, look, we have 5, and the answer was 9. All we did was switch the ones between the two parts. We flip-flopped the ones, we got the same whole. We got the same whole. Alright guys, so did you notice the pattern that was forming? Let's zoom in on a few problems just to make sure we're seeing the pattern. Let's look at 4, 5, and 6. What is happening? What am I doing? Correct. I'm increasing by groups of 10. My ones, the addition I already did of adding my ones is staying the same, but I'm adding another group of 10s each time. You can treat it that way. And notice that you're making moves here. Alright guys, let's go ahead and continue with our lesson. Come on.
Great work on that sprint. And as you can see, we skip right on. Skip right ahead. There's no application problem. That's because it's all word problems. Yay! No, just me? Just me? Oh. Well, it's all word problems. So when we've been doing the last few lessons, our word problems, there's been multiple word problems for one, but I've also been previewing a strategy called tape diagram with you, and that's what we're going to focus on today. So like, for example, this problem here given, it reads, Lee saw 6 squashes and 7 pumpkins growing in his garden. How many vegetables did he see growing in his garden? Okay, what we're going to do is we're going to look at it as such. So what we're going to do is we're going to draw a box to represent the whole. We're going to split it to show that there's different parts. We're going to bring those parts together with the connecting lines to show the whole. And we're also going to label it. So this is the picture, number, and label to show the 6 squashes Lee saw in his garden. And then there's the drawing, the number, and the label to show the 7 pumpkins. We wrap that up with a number sentence. 6 plus 7 is equal to 13. Granted, we still have not answered the question because in it being a word problem, it does require a word answer. He saw 13 vegetables growing in his garden. So the smallest number of words you can put and be correct would be 13 vegetables. But I don't know how to spell vegetables. It's okay though, because if you go back to the question, the actual question in the statement, how many vegetables did he see growing in his garden? Well, first off, you know this is the actual question you're answering because it ends in a question mark. The word vegetables, you copy it out of the question. That's how we find them. We copy them out of the question. So 13 vegetables, the number and what it is we are counting, that is the minimum correctness. This is more correct because it is a complete sentence. Complete sentence answer, okay? All right. So, like I said, we have one part, we have the other part, and we show to bring them together to solve. So let's go ahead and we're going to do the whole of it. From page 79, so red 79 means it's in our Red Trim Succeed book, page 79. We're actually going to do all 4 of them. We're going to do all 4 of the given word problems that are in your homework book. Okay? Now, let's read this. So we're going to read the word problem. We're going to draw a tape diagram and label. So read, draw, and label, and then write a number sentence and a statement that matches the story. If we don't tick all the boxes and do all the pieces, then we haven't answered the question. We haven't completed our job. So this, again, is called a tape diagram. And it is a picture to show 2 parts coming together to make a whole. Now, what you'll notice in this particular tape diagram, the way it is colored, and this is important for what we're doing, it is this group, this part is 12, but they started coloring in once they finished the first 10. 10 once they finish the first 10. Good. Because they want to be able to, when it's all said and done, say, oh, 10, 11, 12, 13, 14, 15, 16. 16 is my whole, okay? So that helps them to be able to solve the problem. So now, it does say read the word problem. But what I like to think of it more so is read and reread. So we can just read it through one time. And then the second time we read it, we will pause to identify information we can draw. Now today's tape diagram, and we'll go ahead and help you out here. Our problem type today is part plus part equals whole. We don't know the whole in these particular problems. And so just giving you that heads up, we're putting parts together. Now I want you to pay attention to the different ways in which they word that the information is both parts. Because all the problems today, we're looking for the whole. But the wording is not going to be the same each time. Okay? Okay, so this one reads, remember, read and reread. Darnell is playing with his 4 red robots. Ben joins him with 13 blue robots. How many robots do they have all together? Okay? So, right now we know that there is some stuff. We know that this is our model. It's the tape diagram. Empty blank tape diagram. We know. Let's go back and read. Darnell is playing with his 4 red robots. Stop. Let's draw Darnell's 4 red robots. 1, 2, 3, 4. That is my first part. Now I've split my tape diagram to represent that this part does it. Cool. 4 red robots. There's 4. But what's missing? I don't have a label. Good. Well, what I want to label it with, there's a couple options. We can either label it with a D for Darnell, or we can label it with an R for red. Let's go with the R for red. So there's 4. That's the first part. Ben joins him with 13 blue robots. So here's Darnell and his 4 red. And here comes Ben with his 13 blue. They're putting their robots. It says, how many robots do they have all together? We want to put the robots together. Okay? Okay, so let's go ahead and draw Ben's robots. Okay, his 13 robots, right? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. Why did I all of a sudden randomly start coloring it in? Because I finished this group of 10. Now, do you think that that was the easiest way to go about doing this? Like identifying a group of 10 and some more? No! This is why we read and reread the problem. Because it's an easier problem if we start with the bigger part. Just like when we count on and we put a part in our head, we put the bigger part in our head. So let's try that again. Let's try that again. If you already drew it and you're looking at me like, oh my gosh, just erase the whole thing, don't erase it. Mark it out and just move down. Just move down. We got a little bit more room in the box, okay? All right. So we said, let's read it again. Darnell is playing with his 4 red robots. Ben joins him with his 13 blue robots. How many robots do they have all together? Let's underline our question. How many robots do they have all together? That's the question because it ends in a question mark. That is the actual question. Now, let's start with the larger part. Who has more robots individually? Ben or Darnell? Ben, correct. How many does Ben have? 13. 13. So let's draw to represent Ben's 13 robots. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, let's box in. Let's draw our box. Let's indicate, let's draw to show this is the part, and we are still trying to find the hole. Now, this group of 13 we're going to label with a capital letter B, and I choose a capital B because a lowercase b, if you're not writing neatly, may accidentally look like a number, and we don't want to risk that. So that's why I say use a capital letter B. Okay? Okay. Now, are we done? No. Now we can add Darnell's 4 red robots. So 1, 2, 3, 4. Good. So now there are 2 different number sentences depicted here. There is the number sentences that represent Ben's robots plus Darnell's robots equals all the robots. Then there's the number sentence that represents 10 and some more. Which number sentence should you write? The one that matches the problem. Good, so let's write that. So we can start with 13 after we've labeled the red robots. We can say 13 plus 4 is equal to blank. We don't have to start with the 4, but we can't do for our number sentence is say that 10 plus 7 equals our solution, because that doesn't match the question. Now we can use, and we drew, so we can say 10 plus 7 or 10, 7, which is 17. We can draw in a way that helps us solve the problem, but the actual problem, what we're being asked, is Ben's robots plus Darnell's robots equals 17 robots. So in answering the question, they have 17 robots. They have 17 robots. You with me? Mostly. Okay, don't worry. We're going to do 3 more together before I send you on your own. All right, so let's clean this up and go ahead to the next problem. All right, the next problem reads, Rose and Emmy had a jump rope contest. Rose jumped 14 times and Emmy jumped 6 times. How many times did Rose and Emmy jump? Now, we've read the problem. Now let's reread the problem. Rose and Emmy had a jump rope contest. Is there anything I can draw there? No, but it tells us what my that there are 2 parts. There's Rose's jumps and there's Emmy's jumps, okay? So Rose jumped 14 times, okay? So let's underline that because we're going to be able to draw it. And Emmy jumped 6 times, okay? So then also underline her 6 jumps. How many times did Rose and Emmy jump? Notice, it doesn't actually say all together, but this word here, this and, I don't want to squiggle in it, because squiggly means verbs. That is not a verb. No, we're not going to confuse. I will not do that. This word and, right here, why do I want to make it squiggly? My heart wants this to be squiggly, but that's wrong for what we're doing. This word and, straight line, there we go. This word and means putting these things together. And is like plus in our talking language. So Rose and Emmy jumps, even though it doesn't say together, that and means put them together, okay? All right, so in drawing and completing our tape diagram model, whose jumps should I draw first? Rose's 14 jumps or Emmy's 6 jumps? Rose, correct, good. So let's this time draw a nice big old tape diagram. So So we know that there are two parts that are going to fit in here because we're putting all the pieces together. Right now, what we know is that we don't know the whole. The whole is unknown. We don't know how many jumps. We know that Rose jumped 14 times. So let's draw to represent her 14 jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is the first part. That is the first part. Now, here's my question to you. Did I make this long enough to include all of Emmy's jumps? So what do? That's what the eraser's for. Just make the box bigger. Just make the box bigger. Now, should this side of the box be the same size as that side of the box? No, because there's more in there. That should be bigger if this is all connected to make one larger whole. So now let's draw to show Emmy's 6 jumps. So 1, 2, 3, 4, 5, 6. Okay? We have over here, we have Rose. Over here, we have Emmy. 6 and 14. So 14 and 6 is... I don't know. I could find it. I could use my tape diagram. So Rose's jumps plus Emmy's jumps equals... I don't know. Let's write our number sentence that matches the problem. Let's write our number sentence that matches the problem. So 14 jumps plus 6 jumps equals blank number of jumps. Now, based on how I colored it though, what is my number sentence to help me solve it? Well, 10 and 10. What is 10 and 10? 10 and 10 is 20. Good. So what is 14 and 6? Good. 14 and 6 is 20. Am I done? Okay. Do I have a labeled tape diagram? Label. Yeah. Do I have a number sentence? Yeah. But it's a word problem. And I don't have a word answer. They jumped 20 times. They jumped 20 times. Remember, notice, these are all putting together the part type problems, but it's written a little bit different each time. A little different each time. Okay, let's go on. All right, you ready? All right, read, draw, and label. Right, number sentence and words. All right, so Pedro counted the airplanes taking off and landing at the airport. He saw 7 airplanes take off and 6 airplanes land. How many airplanes did he count all together? Okay, so 7 airplanes taking off, 6 airplanes landing. Those are my what? Correct. Those are my parts. Good. Those are my parts. Now, let's make our tape diagram to reflect our parts. Because they're coming together, all together, to make our whole. So we know. So based on those numbers, these two should be about the same size. 7 and 6. My parts are almost matching, right? Yeah. But whatever the whole is the thing that we are trying to figure out. So let's draw how many airplanes he saw take off. So take off was 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Take off was 7. So this is take off. That's how many planes he saw take off. Here we're going to now put the 6 planes that he saw land. Watch how I do this, okay? 1, 2, 3, 4, 5, 6. And I'm going to label it with an L for land. What happened? I started coloring it in once I completed a group of 10. Correct. So that is 10-3. 10-3, Pedro counted 13 airplanes. Is 10-3 the number sentence that matches this question? No, it is not. Takeoff plus landing equals airplane. So takeoff plus landing is the number of airplanes he saw. So Pedro counted 13 airplanes. Tape diagram with labels, number sentence, words. Check! We got it. We're done. We did it. Bam! All right, let's do one more. You ready? Okay, by the way, this was on the back side of that same sheet of paper. We just turn the paper over. Not even like true turning the page. We just turn the paper over. Okay, let's do one more together. So this one reads, Tamara and Willie scored all the points for their team in the basketball game. Tamara scored 13 points and Willie scored 5 points. What was their team's score for the game? Okay, listen to the way the question is worded. What was their team's score for the game? This is another situation of putting the pieces together, putting the parts together. It tells us we want to know what their team score is, right? Yeah, but it also tells us that Tamara and Willie scored all the points. So what I need is Tamara's points and Willie's points to put them together to know how many points were scored in the game. So we want Tamara and Willie's points all together. Tells us how many points the team scored. So let's draw a picture, specifically a tape diagram. Last time picture, not just any old picture. A tape diagram to show. First, tell me, who scored more points, Tamara or Willie? Tamara did. Tamara scored 13 points. So knowing that's the larger part, just like if we were counting on, this is what we're going to put in our head, or in this case, first in our tape diagram. So let's draw Tamara's 13 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That is this part. That is this part. That is our first part. Let's write our number sentence simultaneously part. So this number represents Tamara's points. So Tamara's points and Willie's points. 1, 2, 3, 4, 5. So Tamara's points and Willie's points is the points scored, their team scored. So Tamara's points and Willie's points, that's the number of points their team scored. So let's use that counting on. So we know that this is 13, 10, 3. So 13. What's next? 14, 15, 16, 17, 18. So 13 and 5 is 18. Am I done? No, I don't have any labels. I don't have any words. This is wrong. I mean, technically it's the right math and it's the right answer, but I have not finished my job. So this needs to be labeled. We can label this with the letter T for Tamara, and we can label this with the W for Willie. And then we need to know, what was their team's score for the game? Their team's score was combination you can have and be correct? We've talked about this before. The number and the object. In this case, it is the number and the points. This game would be 18 points. So, their team score for the game was 18 points. Okay, now, we've practiced a few times. It's time for you to fly free and do it on your own. Okay, so that being said, you're going to proceed to your problem set, which is in your Learn book, the flower beds, on page number 121. It is front and back as always, and it is all word problems. I just felt a collective panic from everybody. But what if I can't? I don't have... I've already thought about that. This is me reading each and every word problem to you from page 121 and 122. So you were on number 1, click to hear it. You're on number 2, click to hear it. 3, click. 4, click. 5, click. Where's this? Right above the Nearpod. It's in the assignment. So you go into the Nearpod, and then when it's time to come back, this is gonna open. It's gonna be right there. It's right there. It's all together. So once you've done that and you've heard me read the problems to you, go back to the Nearpod and complete your exit ticket. Now, if you've got someone else there to read the problems to you, don't worry about it. If you can read them on your own, don't worry about it. But that resource is available to you. I already thought about this. I thought about this. It's a word problem. I'm not gonna throw you out there on your own on a word problem. That's just rude. Alright guys, but yes, you'll come back, you'll complete your exit ticket using the tape diagram strategy. Applying the tape diagram strategy, showing me what you've learned. Read, draw, and label, write numbers and words. That's all I have. I'll see you guys later. Bye.